In this video, we're going to take a look at how to find polynomial functions given their zeros. Okay, but before we do that, just recall that if you're given a function like this is a polynomial function in factored form, factored as the product of three linear factors. Just remember that if you're given this factor, that corresponds with a certain zero, right? We've done this before. Set our factors to 0 and solve, right? That is a 0. So in other words, if x minus 3 is a factor, x equals 3 is a 0 or an x-intercept, right? And you would get another one here and another one here, -4 and -8, right? So if you're given a polynomial, you can find the zeros. Now we're going to go the other way. For example, I'm given some zeros and I need to find the polynomial, okay? So directions say find a fourth degree polynomial with the given zeros, -1, 0, and 2i. So the very first thing we have to recognize is that complex zeros like 2i come in conjugate pairs, right? So if 2i is a factor, we need to realize right away that so is -2i. Just a little trick to the question that wasn't given. You have to know that if you're given only one complex zero, there's automatically a second, okay? From there, we can write our factored form, right? If x minus 1 is a 0, that means x minus that 0 is a factor. If 0 is a 0, then x minus 0 is a factor. Probably don't need that, but I'm just trying to develop a pattern here. If 2i is a factor, then x minus 2i, if 2i is a 0, then x minus 2i is a factor. And if -2i is a 0, then x minus -2i is a factor. Okay, so you'll notice the pattern. Subtract the 0, giving you the factor. Now, let's clean this up a little bit. X minus 0 is x. X minus -1 is x plus 1. X minus -2i is x plus 2i. So I would write it like this. X times x plus 1. I just moved this guy to the beginning. X minus 2i, x plus 2i. Okay, and then, so there's my polynomial. However, we don't want these complex numbers in the polynomial, right? And we can actually take care of that rather easily. X times x plus 1, and I can multiply these two guys, right? In this case, it's easy to do. X minus 2i times x plus 2i is x minus 4i squared. I don't need to FOIL that because I'm multiplying two conjugates. X times x plus I. Remember that I squared is -1, so that's x minus 4 times -1. Sorry, that should be x squared. And finally, I have my factored form that doesn't have complex numbers in it as x squared plus 4. Okay, so I'm going to leave the answer like that. We could multiply that out to have a polynomial in descending form. That is a fourth degree polynomial, right? If I were to multiply x times that x would give me an x squared, times that x squared would give me an x to the fourth. Okay, so we could multiply that out, but for this example, I'm going to leave it like that. And we'll do one more example. Okay, same idea here. I can write my function right away. If 5 is a 0, x minus 5 is a factor. If 3 minus I is a 0, then x minus 3 minus I is a factor. And of course, if 3 minus I is a 0, then the conjugate has to be as well, 3 plus I. So this one's a little more complicated. Same pattern though. If 5 is a 0, x minus 5 factor. 3 minus I is a 0, x minus 3 minus I is a factor. If 3 plus I is a 0, x minus 3 plus I is a factor. Okay, so before I get into dealing with these guys, which we're going to have to do, I first need to read the directions a little more carefully. It says find a fourth degree polynomial. So this will give me only a third. I got three factors here. If I multiply them out, I'd have x cubed third degree polynomial. So I can do whatever I want to get the fourth degree. The directions are a fourth degree polynomial. There's a bunch of answers to this question, by the way. The easiest answer would just to be multiplied by x. Right now I have four x's, four linear factors, meaning I have a fourth degree polynomial. Okay, and now the final task is to deal with these guys right here because that's not how we're going to write our answer. We don't want those complex numbers in there. Okay, so what I need to do is just figure out how to multiply these two, and then I'll write my answer at the end. So let's just kind of to the side just do a little multiplication problem. X minus 3 plus I, I'm going to first distribute x minus 3 minus I. How did I get that? I just distributed the negative. And now look what I'm looking at here. I have x minus 3 in both cases. I'm just going to kind of group my problem like this. X minus 3 in both factors and a plus I and a minus I. We know how to multiply things like that. Those are conjugates of each other. So x minus 3, I don't have to FOIL. I just have to multiply the two first terms, which the way I have it is x minus 3, that's my first term. So that would be squared. And then the two last terms, minus I squared. Okay, we know I squared is negative 1. So I can square this out. By the way, I actually have to FOIL this one, right? I'm not multiplying something by its conjugate. X minus 3 quantity squared is x squared minus 6x plus 9, and then minus I squared is minus negative 1 or plus 1. Right? So now finally I can answer the question. I have my first linear factor as x, corresponds to x equals 0. That wasn't given, that's the one we came up with. My second factor, x minus 5, which goes with this 0 up here, 5. And then my two complex factors, the 3 minus I given and the 3 plus I that I had to realize was another 0 because complex zeros come in conjugate pairs. Right? And when I put that in, I multiplied out and I got the following quadratic, x squared minus 6x, 9 and 1 is 10. Okay, that's my fourth degree polynomial with the given zeros 5 and 3 minus I. I had to put in the 3 plus I, understanding that complex zeros come in conjugate pairs. And then my choice, the option for this one was to bring in another 0, anything I wanted. So I picked the easy case, 0, right, the origin. Okay, so there is my fourth degree polynomial with the given information. I could multiply that out to have x to the fourth, but I'll leave it as is.